Hey everybody. So this is a super cool paper, and I think it will be a super cool tool that will be utilized by a lot of people, and I think that this illustrates a lot of things. So the paper is called Diffender, Diffusion-Based Adversarial Defense Against Patch Attacks in the Physical World. And essentially what this paper outlines is a diffusion model that can be utilized to stop prompt attacks or attacks directly against infusion attacks against LLM models or against AI models that can essentially process imagery as well as text. So what a common attack is that people are utilizing is that they'll upload an image and then also they'll attack the image by uploading text within the image. And then so what Diffender does is utilizes diffusion, which is typically used for image generation. And then essentially what it does is it takes an image and then it makes the image noisy, and then it predicts the image and then it creates an outcome based off of that image. But what Diffender does specifically is it notices differences between the predicted image and what is produced from the noisy image. And then in that instance, and then if you scroll further down in the paper with their methods and specifically what they do and how it works, is that they essentially utilize an algorithm that essentially can know and predict text. I think I have to scroll down here a little bit more. Here we go through the experiments. And then, so essentially, they lay out the exact formula that they use as well for this and for their model and for their method. But essentially, what they do is it's a mathematical equation that is essentially broken down and is able to detect what is text in an image versus an actual image itself. And then the difference between those images, essentially between the attacked image and the image with text in it versus the image that doesn't have text, is what comes out with the difference. So here's another illustration of that. You can see the attacked image is essentially simulating text being put into the image, and then through a diffusion process it goes through and then essentially removes the text that is detected in the image. And then so it's not illustrated directly in this paper, but another really common example that I think would be easily proven out based off of this paper and what they're able to do with it would be, say, for example, people are utilizing, for example, resumes, and then they'll put text in white text on their resume, and then so you can't actually see it, but when it gets fed into the LLM model detects the white text, and they do things like fluff their experience or try to get the LLM model to actually say that they're a good candidate for jobs, things like that. So what this could do is essentially be able to detect white text versus the actual text that you would want within that image, and be able to strip those things out immediately. So overall, it's a really cool piece of technology to me, and then it's interesting that what's really interesting is that it's using diffusion in this instance and everything that we know about diffusion to essentially fight against a problem that is AI generated in and of itself, which is the problem of prompt hacking or being able to image hack through different mechanisms. But with this particular mechanism highlighting that it's able to essentially utilize technology and utilize that same technology in a different instance and in a different way that hadn't been thought of before to fight back against those things. And then so I think it's interesting to highlight for a few reasons. The first is that with all of this technology, I think that's important to why research is always necessary when it comes to these things, because it's always a race when it comes to these types of technologies and these things where we don't know necessarily what the outcomes are or what is possible whatsoever on either side of the equation until those things are tested. So with this particular example, it's amazing. Like, if you had told me before I read this paper that you could use a diffusion technique to be able to spot and eliminate like prompt-based hacks in a lot of instances, or image-based hacks of AI models in real-world applications, I wouldn't have been able to hypothesize like the actual method that a diffusion model would utilize for that, and then so it just wouldn't have occurred to me. This is a very creative solution in my mind to a problem, to this particular problem, and I think it's interesting, and to me it also highlights the fact of open source development and why it's critical that all of this remains open source and readily available, is for this type of research to be able to come out, especially as the technology is advancing so quickly, and a lot of companies are just willing to throw the technology out there. The best way that we can get any sort of research onto any of this is through open source means, and then so this comes out through the open source community. This actually comes through China, and so this is a completely like a research institute based completely in China, and all of this research that they did there, and it's specifically at a university. It looks like a joint effort between two universities in China, but the significance overall to this is that essentially it's a battle both ways between the people that are developing bad uses for this technology and the people that are developing good uses for it. And what the good uses are and what the bad uses are indeterminate at this point. We don't know, but it's the fact that AI is able to create creative solutions like this is to me, again, like one of the fascinating parts of this technology overall. Like it's such an interesting application of diffusion models in this instance to be able to solve a unique problem. I never thought that I would be talking about diffusion models specifically with regards towards like AI and data security, and all aspects around security. I figured it would be more like LLM models or maybe some machine learning algorithms, but never a diffusion model. But knowing what this diffusion model does, how it works, it makes complete sense as to what it does once you break it down. But coming to that initial thought required a lot of, in my opinion, creativity to be able to get from there to here. So bravo to them, and I think it's bright for the future with regards towards technology like this, and I think the more that this technology gets exposed, and the more that people and companies and institutions and individuals are willing to invest more heavily, specifically into defense and data security and all of the research and ethical aspects of AI development, I think that we're going to find more and more creative uses like these, and it's going to be more and more necessary to have creative uses for preventing kind of bad actors with AI technology as this technology develops. But it's interesting to note, and that it's always there, that it's essentially the creative solution that wins at the end of the day, and I think that's both the positive and negative with AI, and it's things like this are interesting. I'll link this particular paper in the description below, and please like and subscribe if you like this content. Thank you very much.